So our next speaker is Rowena Garcia from the Max Planck in Nijmegen. So over to you, Rowena.
Thank you very much. First, I would like to thank the organizers. It's been a lovely roundtable so far. Today, I will talk about children's acquisition of a symmetrical voice language. So I will talk about I will present our experiment on Tagalog. I use the term Tagalog here, but it is the same as the Filipino mentioned in the Talk Together presentations. Most of these projects were in collaboration with our group leader, Dr. Evan Kidd. So first, I would like to start with this. Most of our knowledge on language acquisition actually comes from studies on English and other Indo-European languages. So this bias means that these languages are taken as the prototypes for acquisition. So even though we know that the languages of the world show a remarkable amount of diversity. And the field's reliance on a small and unrepresentative sample of languages has no doubt skewed theoretical development, making research on understudied languages an important priority. Typically, these understudied languages are those spoken in developing countries, and we put our own data in this category. In particular, we investigate thematic role assignment. So in daily communications, listeners would have to identify who did what to whom in a sentence, and different languages use a variety of features such as word order and case marking to assign the agent and patient of the action. So there are also competing accounts for these. So for example, we have the early abstraction accounts. So for this, there are claims that children acquire abstract knowledge of linguistic structures at an early age, and that they share the same grammatical representations as adults, which they can implement online. Moreover, it's claimed that sparse input does not lead to a delayed acquisition of a particular structure. In contrast, experience-based accounts place high importance on input-driven acquisition of knowledge. So it's claimed that children use the distributional frequencies of the ambient language to calculate the most probable continuation of the sentence. So essentially, the continuations that are frequent in the input. So here, the ease of processing is related to how close the predicted structure matches what is actually heard. And we tested these on Tagalog because of its unique properties, which I will now explain. So Western Austronesian languages have typologically rare but theoretically important voice systems. So Tagalog has more than one basic transitive construction, which are equally marked by voice morphology. That's why we say symmetrical. There's also no demotion of an argument, unlike in English passives where the agent becomes an oblique. And there's also no preference for the agent to be the subject. So we could really see here that it provides an important testing ground for theoretical approaches to the acquisition of verb argument structure. More specifically, Tagalog is verb initial, and its post-verbal arguments are relatively free. So in this voice marking system, the voice marking on the verb tells us the thematic role of the noun phrase that is marked by ang. So in yesterday's presentation from this was called focus. So the agent voice infix tells us that the ang phrase is the agent, while the patient voice infix in tells us that the ang phrase is the patient. So we have seen from written corpus and on our analysis of Dr. Marzan's child directed speech that the patient voice is actually more frequent in transitive sentences. So this will be important for our predictions for the experiment. So I will go back to that later. So let's take a look at examples. So in the agent voice infix on the verb hila, pull, tells us that the ang phrase, ang baka, the cow, is the agent of the action. So this sentence, humihila ng baboy ang baka, means the cow is pulling a pig. And here, just with a change in the voice marking on the verb, now the patient voice infix in on the verb pull tells us that the same ang phrase, the same cow, is now the patient of the action. So this sentence, hinihila ng baboy ang baka, means the or a pig is pulling the cow. And another feature of Tagalog is its flexible word order. So even if I change the positions of these noun phrases, if they have the same voice marker, there will be no change in interpretation. Let's take a look at this So now both of these are in the agent voice. Even if here it's patient initial, this is agent initial, both mean that the cow is pulling a pig. And this is also the same with the patient voice, since it's the voice markers that assign the thematic roles. So given these properties, these are our research questions. So at what age do children actually learn the voice marking system? And when can they actually start using the morphological markers in real-time comprehension, as well as in production? And of course, which accounts are supported? So I will talk about these projects. I will briefly talk about about the child-directed speech part of our corpus for better predictions for the experiment, just like how the Talk Together project does it, and then proceed to the eye tracking experiment and production experiments. So our data were collected from Metro Manila, Philippines. So we decided to collect a cross-sectional corpus. So in comparison to the Marzan data, the participants are dominant Tagalog speakers and also from low socioeconomic status. You can see here, we provided these toys, these picture books. So it was actually semi-structured. And we did this because our target was really verbs. We wanted to have as many sentences with verbs as possible. So we had 20 child guardian pairs, and the children were between 2 and 4-year-old. So this one I'm showing now is just from the verb initial, highly semantically transitive sentences, which are almost similar to what we use for our experiments that you will see later. And just from these, we could actually see that similar to our previous analysis of Marzan's data, we see a lot more patient voice than agent voice. What is also obvious here is that there are a lot of verbs that are actually not inflected for voice. So take note, these are actually not grammatical. So they're supposed to be, at least if they're not in recent perfective voice, they should be marked. So we also found an agent initial preference. So in both agent voice or patient voice or in the uninflected, we see that most of the utterances mention the agent first. So again, more patient voice than agent voice, mostly agent initial. And I just want to mention that I presented just the verb initial, but actually in the whole child-directed speech corpus, it's also mostly, I think, 80% verb initial. I'm rather interested whether this is the case in print, since the fronted I form or the SVO in Tagalog is supposedly more common in written language. So I'm also curious about that. So given these findings, let's take a look at our comprehension experiment. So here we were checking the online use of the morphosyntactic markers. So let's go back to the accounts. So we think that the early abstract parser account would predict no voice difference. They should acquire knowledge of these structures early on and should be able to use them online. In contrast, for the experience-based accounts, we think that there would be a patient voice advantage given the higher frequency of the patient voice in the input. So for this, we use an SMI Red-M eye tracker. We had 5-year-olds, 7-year-olds, and 9-year-olds. We also had an experiment with adults, but I will not talk about it now. Maybe you could ask me about it during the discussion. So we manipulated voice and word order, and we looked at the proportion of looks to the agent. So this is a sample. They first saw an action picture like this, and after 1,500 ms of preview, an audio recording of a sentence matching this picture was played. So this picture remained on the screen throughout the trial. So I will show you an example of the stimulus. So this one is an agent voice agent initial sentence. So what we're checking is whether after upon hearing the voice mark verb and also the first noun marker, if they could predict the upcoming argument. So actually, if they use the morphosyntactic markers, and given this context, by this point, by the first noun marker, so this is our critical region, they should already know the upcoming noun. They should know that the agent should come next, so the cow. So what we're really checking here is whether they already look at the cow even before the cow is mentioned in the sentence. So at this area. So for the children, we actually had comprehension questions. So either an agent. So half of the trials were followed by these questions. So either an agent voice or patient voice. The agent voice was always asking for the agent, and the patient voice was asking for the patient. So let's take a look. Actually, for the eye tracking experiment, we excluded the few 5-year-olds who had accuracy scores below 75%. And this was just to ensure that the children knew the difference between the voice markers. We could discuss this result later as well. So let's take a look at the eye tracking here. So this is for the 5-year-olds. This is the agent voice condition, the patient voice. The red lines are for the agent initial condition, the blue for the patient initial condition. And the orange shadings here show the significant clusters identified by the permutation analysis. So here we actually see no prediction of the first noun in the 5-year-olds. You can see here they showed more looks to the agent in the agent initial condition only after the noun has started to be mentioned. Notice though that this divergence is still earlier in the patient voice than in the agent voice, showing a patient voice advantage. Let's take a look at the 7-year-olds. So here we actually see that, like the adults, there is prediction of the first noun, but this was only in the patient voice and not in the agent voice. So we actually see this here, our difference starts even before the first noun was mentioned. Unlike the adults, though, who showed looks to the second noun even before it was completely mentioned, we see that the switch only occurred after the second noun was completely mentioned. So we still see a difference in speed of processing there. Let's take a look at the 9-year-olds. Here, like the 7-year-olds and the adults, we see prediction of the first noun in the patient voice, but not in the agent voice. We also see a short cluster of 124 ms here, but it's puzzling that the children did not pursue this interpretation. So we are a bit hesitant to interpret this as prediction of the first noun in the agent voice. So what we see here is that adults and older children can predict the upcoming first noun, but that this is dependent on voice. So even if both morphosyntactic markers appear early in the sentence, the voice distribution had an effect. So we can say that the patient voice advantage is consistent with the higher distribution of the patient voice, as well as with the claims of the experience-based accounts. And more importantly, what will be the impact on assessment and intervention? So based on this study and even on our previous eye tracking experiment, we actually found that the patient voice agent initial condition, so this structure is what children understand best. So it could be that, I suppose that language of instruction or the sentences in our story should be in this structure. So patient voice agent initial. And perhaps it also tells us that we should provide more support for the agent voice, or at least I'm very curious about how atypically developing children perform in these tasks. So this has not yet been done. Perhaps we need to explicitly teach these. So even in schools, this is not explicitly taught. This is not part of the curriculum.
Rowena, you've got a couple of minutes left.
Thank you. So I have the production experiments here. These were actually supposed to be about word order preferences and the kinds of information that children use to learn word order. But for the Talk Together project, I think the most interesting one would be the use of morphosyntactic markers in production. So I will just skip to those results. So we had a sentence completion experiment. So children saw a picture like this, and then they heard a voice mark verb prompt. So either agent voice pull or patient voice pull, and they were supposed to use this verb prompt to describe this sentence, so to complete that sentence. So we were just checking whether they will say the cow, a pig. So we had here 5-year-olds, 7-year-olds, and adults. Again, I will focus on the use of the morphosyntactic markers, so on their noun marking accuracy. And what I would like to show here is that our 5 and 7-year-olds still had errors in using the nang and the ang markers. More importantly, what we see here is that most of these are reversals, and that this is more frequent in the agent voice than in the patient voice. So we could see in both of the studies, we actually see that there were more errors in the agent voice than in the patient voice. children were using the patient voice mapping, even if they got an agent voice verb prompt. This was also the case in our more recent priming experiment, but you could see the difference between the 5 and the 3-year-olds. So what we could see here again is a patient voice advantage in noun marking. And again, we should probably think about whether we should explicitly teach this. I would just like to mention though that these tasks are more demanding than in spontaneous speech. So we gave them a voice mark verb. So maybe they were prepared to use the patient voice, but then they were given the agent voice and had difficult time revising this. So overall, I would just like to say that at the age of 5, Tagalog-speaking children still do not show adult-like use of the morphosyntactic markers. But I'm not saying that they cannot use these in daily life. Children who had MLU greater than 2 in our corpus already show the use of some markers. But it seems that given more processing load, they still do not perform like adults. So we see the influence of the input distribution, which supports experience-based accounts and can have an impact on structures we use for teaching and the structures we target for intervention and evaluation. Lastly, I hope that I was able to show that research on understudied languages can help us broaden and deepen our understanding of language acquisition and processing. Thank you to our collaborators and to everyone. Maraming salamat po.
Thank you for a very interesting talk. So we've got time for one quick question, and I'm just going to read out the one that has been posted in the Q&A box. So the question is about the eye tracking study. It said, the question is, if children across different age groups displayed similar accuracy score, but the younger groups did not benefit from sentence parsing, what would that mean? So are there some other strategies to help them basically comprehend the sentence?
Yeah, thank you very much for this question. So it's also, we were also considering this a lot. So either they already know the markers, but somehow they're still slower in processing, or maybe it could be the case that children's representations are still weaker or still different from those of adults. So we were thinking about this as well. For example, for this accuracy, for this comprehension question, maybe they could even have a heuristic there. So if you hear an agent voice verb on the agent voice mark verb, you could just map it to an agent. So you don't really have to do the ang or the subject mapping to an agent. So we were thinking maybe that was the key. That's why they performed well on that. But given a more difficult sentence, let's say if they really have to interpret a sentence like the cow is pulling a pig, that they would have more difficulties. So we had this on a previous experiment, and we saw that children actually had difficulties with agent voice patient initial sentences. So they were not using the morphosyntactic markers there. So we think maybe if there's a task that is more difficult, that requires more processing load, maybe that's where we see the issues. But again, I also presented in production, they seem to also make errors if, again, the task is rather difficult.
Okay, great. Thank you very much, Rowena.